One of the most fascinating aspects of matter is that it exists with seemingly infinite variation. Indeed, without such a great variety of forms, life would likely be impossible. That is why it is noteworthy that all matter, at least the matter that is most important to us here on Earth, is built from a relatively small number of components. In this first module, we will introduce those fundamental components, discuss their defining properties, and learn about the forces that hold them together. Interestingly, a few basic concepts about these constituents of matter and their forces are sufficient to guide much of our understanding of atoms, molecules, and their respective properties. Module 1 is organized into several lessons, each providing you with a gradual introduction into the nature and properties of the elements. The first lesson sets the stage for the course by defining some basic terms and introducing the mathematical sign conventions that we will use in our descriptions of force and energy. This lesson will also provide some background, if you need it, on the metric system of units and the various prefixes, kilo, milli, nano, that are used to modify the magnitude of the units, as well as the use of scientific notation to denote numbers. This is followed by a treatment of the most important forces that influence molecular structure, electrostatic forces. Electric charges are governed by Coulomb's law, and although you will see the mathematical statement of that law, our emphasis will be on developing a deep and intuitive understanding of what the law represents. These concepts will then be used extensively throughout the remainder of the course. The forces described by Coulomb's law are responsible for the structure of atoms. We will see how the structure is influenced by the much lighter mass of electrons relative to neutrons and protons. The energies of the electrons in atoms will also be important. It turns out that particular arrangements of electrons are energetically more stable, and this guides how atoms interact and combine with one another. Once we understand something about atomic structure, we will turn to the relative properties of atoms and the elements that they represent. These relationships are summarized neatly by the periodic table of the elements. Even better, we can use some of our newly developed intuition about electrostatic forces to understand trends in physical properties within the periodic table, including such things as atomic size and an atom's relative tendency to lose or gain an electron. Finally, we will conclude the module by pulling all of this information together to recognize patterns in the stability of certain electron arrangements or configurations. These observations are succinctly summarized by the octet rule. This rule guides our understanding about how atoms can form chemical bonds, which are the strong attractive interactions that hold atoms together. For many of you, this module may seem like a review, especially if you've had a prior course in chemistry. Indeed, the approach we are taking is to assume that you have no familiarity with these subjects. As a result, some part of this treatment will inevitably be well known to you already. However, don't be lulled by this familiarity. Many of the underlying themes presented in this module will be crucial for future modules, and the presentation here is more focused on understanding fundamental relationships rather than on memorization of factual material. If you understand the root cause of the phenomena we present, you'll be better equipped to succeed not only in this course, but in any future applications of chemistry that you may encounter. So let's get started.